Hello Internet, this video is going to be a little bit different. We're actually moving to Java for this one. So I've been looking at something called the Reactive Extensions. It's a programming design that's kind of based around streams and how to stream data between things. I believe it was originally designed by Microsoft, but it's been picked up and adapted everywhere. So this is available in .NET. There's even a Unity extension for this. Python, Java, as we're going to be using, and like 20 other languages. I'll post a link to the site if you guys want to check that out. But I've been playing around with this, and I think it's really cool, so I kind of wanted to show you guys. So I've been working with the Java stuff mostly, so that's why we're working with this. And also, I don't think .NET Core is... Well, actually, .NET Core is supported, but it's a little bit tricky, and there's no NuGet package to my knowledge, so I think that's still under development. But anyway, what I have right now is just a really basic Java application. This should look almost identical to like a C# application or anything else. This is Hello World, and you can see it's got the display down here. We just print out Hello World. The issue, I've never run this in presentation mode before. I've never actually coded in presentation mode before of IntelliJ, but we're gonna try and see what happens. I'm gonna zoom my camera in. All right. So now that that's fixed, what we need to do, so I can run this. If I just run the application, it will go. We'll see Hello World. You already had that because I was already running this. But I'm thinking we're going to build FizzBuzz because that's sort of the go-to for me, just because it kind of covers things like loops, logic, and a few other things. So what we're going to do is use this observable. So there's a bunch of observable things. We want this io.reactive-extensions thing. So I'm going to create an observable.from, and I'm going to, So we can create this from some array. So let's create it from an array. I'm going to create just an integer array here of values. Sure. So we can just create that as an int array of like 5 values, and we'll just set value 0 equal to 0, and so forth. I could have done a loop for this. That would have been smart. There's a bunch of helper functions to do this. I've actually been working a lot in Groovy to do a lot of this, which makes it even easier, and Python too. But anyway, so we create this from array. We are building this. So what I'm doing is I'm creating a stream. Think of it like a listenable. If you've ever worked with iterators or link in C#, it's like that. If you've worked with Java streams, it's also going to be very similar, but it's a little bit more advanced. So here I'm going to take this array, and I'm going to actually just subscribe to it and do something. So we're going to take a lambda, I'm going to do t, and I'm just going to print out t. And so what this is actually going to do is it's going to feed these values into this observable, and then our subscriber is going to see those values come in and publish them. So if I run this again, we should see Hello World come up, and then we should see 1, 2, 3, 4, 5, and we don't. From array values. That's not good. Let me read. So one of the cool things about this is all of this is Java. Whoa. All of this is, well, Java, but also it's all asynchronous, which means that everything you do here can be made asynchronous very easily, which is good and bad. I haven't actually touched the Java version of this now that I'm considering this. but whatever. All right, so it's gonna stop here. We haven't exited yet because I have a read going. I'm confused though. Oh. Okay, so that's what's happening. We don't actually need that. It's expecting a params thing. So it'd be, this is what it's expecting. So if I give it that and run this, it will work. It was creating an observable of arrays. So yeah, now we get hello world 0, 1, 2, 3, 4, 5. Ignore the asynchronous stuff because that isn't actually happening here. All of this is executing on your main thread. To my knowledge, I'm still fairly new to this, so I don't know. I figured I'd do something because there's no documentation on this for the most part, and what's out there is kind of sparse. So figured we'd look at it because I think this stuff is cool. So what we need to do is create a for loop. We can do this better, actually. So one of the cool things is there is an interval, which means you can give it a millisecond wait, and it will, so if I give it 10 here, it's expecting something else. I don't know what, though. No idea what it's expecting. One sec. Observable, interval, time unit. Okay. So if I make it wait for, say, 10 milliseconds, so time unit dot milliseconds, so that means we'll get 100 values per second, and this will just keep going, but it'll be a relatively consistent tick. So if I do 100 here, that means we'll get 10 values per second, and it will just keep printing them out, which means I should be able to start this now. Maybe? Why can't I? Oh, because that's still going. Got it. There we go. It's being weird. All right. So we start this, and you'll just see it'll start counting, and it's just going to keep going. So those numbers are never going to stop. It's just going to go at an interval, which is really cool because we can use that for FizzBuzz, and we can just create an infinite list of this stuff, which is neat. But then we can also do some fun things, like say, I want to create a observable t, actually of integers. So Java is a little bit funky. It only can make generics over objects, which ints are not. So this, like int, isn't an object. It's its own special thing, and Java has its own special ideas about what that means. So you can't actually create generic. Well, actually, I think you can. Hold on. That's wrong. Nope. No, that was right. Ignore me being crazy. But if you're coming from like a C# background, as I'm sure some of you are, just because of my audience, Java does generics differently. It uses what's called type erasure, which means that all of your types go away after compilation. So this observable integer only exists at compile time. It will check and make sure that this is returning an int. So this will just be our ints, I guess. But it will make sure that this is returning an integer and that it can be assigned here. But you lose that type as soon as it's compiled. This just becomes an observable of objects. That was done for backwards compatibility reasons back in the, I think, 90s. But anyway, I don't like it. But anyway, that exists. We can create this. Created an observable of type long. Okay, that works for us. So we get a long observable. So I have no idea if this is actually going to work, but we should be able to actually do some fun stuff with this. I can filter everything down. So we'll have our items. And I want, if our item, will this work? So what we can do is we can actually pass this to some sort of function that will print out FizzBuzz, whatever. But there is actually a whole slew of functions here that I'm still not very familiar with that can do pretty much anything. These are almost more thorough than like link, because you can do joins and link and all that, but you can also like and things. You can do ambiguous stuff, which means it will, if you have like two concurrent tasks running, it will take an ambiguous one will take whatever comes back first. So if you have two things that are equally good and you just want whichever one can get there the fastest, you can use that. There's a whole bunch of other things. Buffer is another cool one, because it will actually accrue things for a certain amount of time. So like say you're trying to detect a mouse click, but you don't want double mouse clicks to count as two separate mouse clicks. You want them to count as a single mouse click. What you can do is create a buffer, and then when you click the mouse once, it will hold that click for a specified time span, and then if another one happens within that time span, it just gets accrued and added to the other one. But anyway, I'm getting a little bit lost here because I don't really know. Like, so we can filter things. So I could take our item and say if the item mod 3 dot mod 3 is equal to 0. So this will filter everything and only return the numbers that are divisible by 3. And then we'll subscribe and say item system out print line, I think it's fizz. This may not be correct. I'm thinking this won't work, but I want to just kind of run through it. Especially this part. This part definitely won't work. So if it's divisible by item and divisible by 5 and 3, then we want to print FizzBuzz. That's the part that doesn't work, because we're going to want only one of these to respond. I don't know how to handle that, but I'm going to have to find out, aren't I? And then the final one is just going to be printing the number. So if none of those are true, then we print the number, which means we're going to need some sort of conditional stuff, I think. I don't really know if this is actually a good good thing to implement with reactive stuff, but it seemed like it was kind of a fun thing to try. So that's what we're going to do. I'm going to make that return true, which means this whole thing is going to have a very interesting result. We should see like FizzBuzz and the number printed out. If it's like divisible by, if we get 15, for example, that's divisible by 3 and 5. So this is true. It's divisible by 3, and it's just the number. So all of those should happen. So this should not be correct at all. Yeah, so if I stop that, yeah, that's not even close to being correct. So I guess now we have to figure out how to fix it. And I have no idea how to do that. So we have... Let's see here. We're going to need 2 streams. So if both of them... Yeah, I think so. I think we can solve this using 2 streams of these. So we're going to take our initial thing, and then we're actually going to split that up into things that are divisible by 3 and things that are divisible by 5. And then... I may need to draw this out because it's going to take a little bit. So let me draw it out, and then I will come back. I'm still trying to figure out how to think like this because it's a very functional style, and it's totally different So let me figure out how to think like this, and then we will be right back. So it's a little bit more complicated than I thought. Part of the issue I'm running into is I don't think there's any good way to handle this case, because there's no way to prove that you would need to filter by this mod 3 and this mod 5. But in order to get this, you need to prove that the value doesn't exist in either of those two lists, which is actually kind of hard to do, unless I'm overthinking this. But I don't know a good way to actually prove that something doesn't exist in those sets when those sets are constantly changing. I guess in our case, they're constantly increasing, so we could keep some sort of tally or check. But I don't like that solution, and maybe this just doesn't fit that very well. So anyway, we can do quite a bit more with this. So what I'm going to do is first, we're starting at 0, which I don't really like. So I'm actually going to map that, just increase the item by 1. So this will just up our item. It's actually just mapping the value to something else. So there's that. I'm going to split these so it's a little bit easier to read. So we're going to map and and then subscribe. Let's just stick a FizzBuzz item on there. I'm going to need to pass the item in, obviously. And so that, I keep trying to do the Visual Studio hotkeys, and they are set up in IntelliJ to be Visual Studio hotkeys, but there's some that they missed, like the control period, which just don't exist. And so I keep trying to hit those and they don't work. We're trying to save this. Can't save that. It's now subscribed right there. So this is all just one giant continuous function, which is cool. For this, it's just the classic FizzBuzz. If item mod, that's not mod 5 is equal to 0, and item mod 3 is equal to 0, then system.out, need to capitalize that, system out print line our FizzBuzz, else if our item is divisible by 5. The order of these shouldn't matter, so we're gonna just make it up. System out print line. Let's do our fizz. Otherwise, let's do our buzz. So just set that up like so. And finally, if none of those are true, we just print the number that we have. So this should go 1, 2, buzz, 4, fizz, 6. I didn't say 6, I meant buzz. You must have been hearing me wrong. Let's see here. Item. There we go. FizzBuzz done. So theoretically this should work. And it should just keep going. 1, 2, yeah. Looks correct so far. And so this is sort of really basic reactive stuff. There's a lot you can do with this. I'm kind of learning it myself, but it's really useful for UIs when you need to like react, especially these timer things. When you have these intervals, you can use this as kind of, they actually have a separate timer. Observable dot, I think there's dot timer. Yeah, so you can use, there's a timer and there's a interval. I don't know enough to tell you the difference, but it's there. And some of the cool things is there's two core concepts. There's what's called this observable, which is something you actually watch. But then there's also an observer, which is going to look at something and try to react to it, which is what these subscribers are shorthand observers, if I understand that correctly. And so observers can do more than just this. They don't just process things. They can also do error handling. So if an error occurs somewhere in this stack, they can actually handle errors. And with these, ooh, that's not right. But these things can actually complete too. So they can subscribe and react to those kind of events as well, which means they're fairly robust. And you can have as many subscribers on here as you want. Another cool factor is you can actually do subscribe on, and we can do like a schedulers dot computation, for example. And this, if I just stop this, everything's going to be totally out of order now. But this just made our entire program, or that scheduler rather, run asynchronously. So things may appear out of order now because this is going to be, I believe, equal to the number of threads on my computer. But it will now run that many threads to do this. So you'll have this subscriber running on that many threads, which is a handy way to just quickly get concurrent stuff into your program, which is neat. So yeah, I don't know. There's a lot of stuff to do with this, and if you're familiar with LINQ, it's like an extension of that. It's another functional aspect of working with things, and it's pretty powerful. I think there's a lot of really cool things you can do with this. I think I just learned that there's actually, when I was reading up to do this video, turns out there's a Unity extension for this, and I kind of want to play around with that too. So expect that in the future. But that's it for this video. So if there's anything else you guys want to see, any feedback you have or suggestions on how to use this, because I'm still learning this stuff myself, yeah, if you guys know it, I'd love to hear it, because I'm here to learn as well. So yeah, if there's anything else you guys can think of that I can improve or change to make this better, let me know. That's how I get better too. So yeah, that's it for now. So until next video, see you, internet.